I think it's time to take a look at another of these delightful Oriental industrial components, because they're so widely available and cheaply available on eBay that it makes them ideal for experimental stuff, you know, prototypes. So this is a solenoid water valve, and it's got a water inlet covered by a cap here, and a water outlet. And it's also notable that on the inlet, if you unscrew this little cap, it's got a removable filter, so you can, if it's prone to catching grit in the water supply, you can just take that out. Well, obviously you'd have to turn the water supply off first, but it means you don't have to start decoupling the, you know, taking the pipes off and trying to get the wee filters that poke down the end. This one has this sort of little silicone rubber cap here that once the water's off, you can simply take that off and pull the filter out, change it, or clean it, should I say. And the bulk of it, the main pipe connections are sort of brass material. I say sort of brass material, you just never really 100% know what it's going to be, but it's an alloy that has a strong connection to brass. It certainly looks very brassy. And it's coupled onto this plastic body. And there's a cover which covers the solenoid valve. And I think these are available in quite a wide range of voltages, but this particular one is 12 volts. So if I actually get a 12 volt supply here, let's turn the power supply on. It's set at 12 volts, it's handy. And I shall connect it onto the bottom of that screw in here. And I can hear it clicking in, and it draws 320 milliamps. I can hear it clinking on and off. Okay. So this came from an eBay seller called... Oh right, okay. 94 Racing-AU, but it seems to be a very common item on eBay, and it costs £3.57, which is cheap for a solenoid valve, and the shipping cost was about 60 pence, so say just over £4, which is actually still very good for a you know, powered low voltage DC solenoid valve. So let's take this to bits, and for this I'm going to need a posi drive screwdriver. So let's take everything to bits, see what the construction's like in general. You do get all metal solenoid valves, but I think the plastic ones are fairly common just because they're used in the sort of washing machines and stuff like that. So here is what looks like a one-way valve on the output designed to prevent backflow, I presume. And it's got a sort of silicone rubber washer that just presses into that. There's not really much else to see in there, is there? So let's put that back in then. Oh. Which way around did that go? No, I'll put it in that way. It seems logical. Because then it presses into the middle of the thing. Oh no, it doesn't, because then... Oh, blimey. Yeah, this is really coming to bits now. Here's a rubber seal that's supposed to go into this sort of thing here, this little recess. Then I'm guessing that probably actually goes in like that, and then goes over like that. I think that's how it goes. Yeah, probably. It'll probably just leak water everywhere if I ever actually try this. I've no particular application for it right now, but I could imagine applications might be automated plant watering devices or automated fountains perhaps. I will admit that what really inspired me to buy this was seeing the local water effect feature, and I just thought, I wonder what, you know, stuff's available on eBay you could just rough something up like that with. So let's take the other side off. These are just sort of self-tapping screws, so you'd want to make sure they went into the correct thread again, because I suppose ultimately if you chewed up the thread, then there's a risk it's going to not really lock down properly on these silicone washers, and it's just going to leak. But yeah, there's not a lot to see in here. On this side. So yep, I'll pop that back on, and then we'll take the solenoid valve off. Goes together fairly easily. There we go. Now the solenoid valve is held on by 4 screws. I think these are all just a standard self-tapper size. Technically speaking, you could turn this solenoid round, I'm guessing, but I don't think it's keyed in any particular way. We'll check that out. Just if you had a particular application, you wanted the cables to be coming out in a particular direction. Because this cap only goes on in one sort of way round. What's this going to reveal? Is it going to reveal lots of springs? It's probably going to reveal lots of springiness. I have to say, I noticed earlier when I took the filter out that everything's wet in this. Ooh. Right, here's the... So the solenoid itself, I presume that you could just get the different voltages of these because it doesn't actually have anything that physically enters inside. It doesn't have a seal or anything like that because I would say the plunger is in here and it's just being attracted in the magnetic field. In here, oh blimey, yeah, it's come to bits now. Right, okay, let's make sure I note where everything goes here. That's quite interesting. Oh, that is interesting. There's a hole in the diaphragm that this little spring goes through, and it actually goes through the hole here, but as it moves, I wonder if that's a self-cleaning action. Because it's just basically that wire, the spring wire, I suppose it helps align the spring as well. Apart from that in here, we've got a central port, which is the output, and we've got the outer port, which is the input, and there's nothing else to that. And that means all the magic is in this diaphragm. And this plunger. The plunger, this is wet inside. I wonder if it's some sort of sterile liquid, or I presume they test them, or is it just to, I don't know. So here's the plunger with a little silicone rubber cap in the end that's designed to go over a hole in the middle of this because this acts as a pilot valve. And this is a spring in here. Oh, very springy. Let's turn the power supply on and check that out and see it move. So the spring goes in here. The plunger goes in here. The coil goes on. This is going to ping out somewhere, isn't it? Turn the power supply on. I'll just hook it onto these screws here. Oh yeah, that's quite decisive. Will it ping right out? Yes, it does. So yeah. So let's take a look at this diaphragm now. We've got a plastic washer that is popped. It's kind of locked over. Little pins. And one of those pins is a hole through it, and then it's got this central bit that is also just, so this is this is a moving diaphragm, and this is presumably just to give it rigidity. And it seems to be operating this, I'm going to regret taking that off now, it's never going to go back on again. I may have to use extreme subtlety and force to get that to all fit back over. There it goes. Yes, maybe that's better not to take that bit off. So this is using the sort of pressure equalization and pilot valve system, which I'm going to have to draw that to actually make any sense of it. Where's my notepad? There's my notepad. So let's do a doodle of this and I'll show you how this works, how they usually work anyway. So, pen. Where's a pen? Where's a pen? I've lost a pen. Where's a pen? The traditional solenoid valve has this sort of body like this, and there's the water inlet, and then there's the water outlet, which actually has a central pipe that sort of goes down basically like this. And that's certainly what's happening here. We've got the central pipe that comes down from the centre and goes out, and the outer pipe, which the water comes up round the outside. So that, I'll just draw that as the output. So the water comes in, and there's a diaphragm that sits across like this, and the diaphragm has a sort of chamber above it. So let's draw that diaphragm as an actual, kind of like, yeah, that'll do, and a sort of support for the diaphragm. And the solenoid valve comes down from above and just basically has a little sort of rubber stopper that covers a hole in the middle of the diaphragm. And that solenoid plunger then goes up and it's got the outer plastic shell that it goes in, and it's got the spring above it, and then it's got obviously the coil that goes round that. That is just basically, it's a coil of wire. It's just wound round a core so that when it's energized, the plunger gets pulled into the middle like a typical solenoid. Then there's another, in this case, there's another little spring going down here, and there's another pilot hole here, and that spring actually seems to go down through that pilot hole, which is quite unusual. But what actually happens here is that when the solenoid is in its off state, water comes in here, and because this hole is blocked, because the solenoid is not energized and it's just covering that hole, water flows through this hole here, and the pressure on both sides of this diaphragm equalizes. And that means that the springs, it takes very little pressure to push that diaphragm down across and block the water flow. Because effectively this side will be low pressure, this side will be high pressure because this is the outlet. But when you energize that and the plunger goes up, it uncovers that hole, and the water in this cavity up here can then spray through that hole, and it reduces the pressure. It means that there's a path for water going straight through, and it means the pressure of water can push against the spring because it's greater than the spring pressure, and that curves that diaphragm up, and then the water flows directly down here like that. But when you de-energize the valve, it doesn't just instantly go bang and stop the water instantly. There's usually a small delay. It comes down and hits the top of the diaphragm and blocks the water escaping from that hole, which means the water then the pressure equalizes again because it can still get through this hole. And that diaphragm is then gently pushed down by the spring until it seals off, and then that's why they often suddenly stop with a thud just as it closes down to the bottom, and the water flow is suddenly stopped as it caps off. So it means that very little effort is required on this behalf of this plunger. All it has to do is lift off very gently off that tiny little hole there, and that is basically the only action that's required to allow this diaphragm to then get pushed up by the flow of the water and basically open the tap, so to speak. So, or should I say open the tap over here. So it's very interesting. It's very typical construction. I guess ultimately they're mass produced. You know, they're such a common item that, you know, they're used in so many applications that it is just viable to make them in huge quantities. I wonder what the intended application for this one is. General use or particular factory use? But yeah, very typical design and very functional and completely openable and serviceable as well, which is quite nice. So yeah, it's pretty neat. That's quite a smart little component. Now I just have to put it back together again.